higher powers. So exponents. So in this video we'll discuss exponents, or sorry, higher powers, or higher exponent, I suppose. So last week we discussed squaring. This week we're going to go up to more powers. For example, we could have 5 cubed and 5 to the power of 11, or 7 to the power of 5. Now this number here, which is the exponent, can be much higher than 2. But before we get to that, let's actually clarify some terminology, because you probably hear exponent, power, indices, all these words being thrown around and used interchangeably. And to be honest, it's fine, right? I do it as well. But I think if we want to be more precise, let's actually fully get with the terminology, which is, if you have something like this, and just take my word for it, this is 125. Here's what the exact terminologies is. In this case, this is called, the number that's been taken to the power of is considered the base. And 3, which is the amount of repeated multiplications. So actually, let me write the full definition. So 5 cubed means multiplication repeated 3 times. If that doesn't make sense, don't worry, we'll get to that later as well. But the idea is, this term here is the power, sorry, the exponent. And the power is the result. So you could think of it either as this entire thing is the power, or you could think of it separately as just the number itself. Either way, the power is the overall result. So technically speaking, these are not, exponent and power are not exactly equal, but just in general terminology, would use them interchangeably, so it's not the biggest deal. But yeah, if you want to be more precise, however, this is the correct terminology. But anyway, let's get to the actual maths behind this though. So first, we'll go through the definition of higher powers. The definition of higher powers is very similar to the definition of squares. So if you recall, squaring meant repeating multiplication twice. So a squared was a times a. Right, so in words, it's multiplication repeated twice, right, on the same number. Or you could think of it as the same number multiplied together. 2 of the same number multiplied together. But I guess the key idea though is repeated multiplication of the same term. But powers, a to the n, in general, so it's not just 2, means you have n a's multiplied together. So that is very similar, right? It's just a more general version. Instead of being limited to 2, you can multiply as many as you specify in the power, in the exponent, right? This exponent tells you how many a's are there being multiplied together. That's the definition. That's all it is. So some examples of this, you have 2 cubed, for example, is 2 times 2 times 2, which is just 2 times 2 is 4 times 2 is 8. You can have 5 to the power of 4, which is 5 times 5 times 5 times 5. This might take you a bit longer. 5 times 5 is 25, and this is also 25. So it's 25 times 25, which if you do long multiplication for, vertical multiplication, should end up with 0, 25 times 2. Yeah, it's 625. So it's 625. So as you can probably see, the thing about higher powers, they get pretty large pretty quickly, because when you repeat the multiplication, things just stack up really quickly. So now what we'll do is let us first discuss powers of negatives. So you probably saw from last week that when you squared negative, so not negative 4 squared for instance, and remember the negatives inside the bracket, because if it's outside the bracket, you square first, so it's still negative because of BODMAS, right? Or BIDMAS, let's say. You do the index first. So you do the index before this, which is a multiplication. So if you take the power of a negative, so again, keep the negative inside the bracket, it becomes positive. So negative 4 times, which is the same as the positive 4 squared. Let's see what happens when we try to take the higher powers of negatives. Let's do a negative 4 cubed. Do you guys think this will be positive or negative? Well, it turns out, actually, I won't reveal it. Let's actually do it properly. Just do it from scratch. So you have negative 4 times negative 4. You have two negatives multiplying together. What happens? The negatives cancel. So it's just 16, positive 16 times negative 4. And that's negative 64, because there's only one negative now. So this one turns out to be negative. That's interesting. What about negative 4 to the 4? It's negative 4 times negative 4 times negative 4 times negative 4. Now this is going to get a bit large. So let's focus on just getting the sign instead of worrying about the value. This two cancel. And then these two also cancel. So in the end, you'll just have 4 to the power of 4, which I'll tell you right now, it's 256. I don't want you wasting time. But the key was, at 4, these two cancel together, and these 4 paired to cancel the negative. Sorry, these two. So as you can see, the negatives cancel here. It's positive. Do you guys see a pattern? The pattern is negative something, or negative a, let's say, to an even power, or negative a to the even, write it like this. It just becomes the positive number to that power. Why? Because all the negatives cancel. So you can see, so you have a bunch of negative a's multiplying together. If there's even number, you can pair them up really nicely. Every single one will pair, right? And when you pair them up, the negatives cancel. But when it's to the odd, what happens? Not all pairs cancel. There's an odd one out, right? That's why it's called odd. There's an extra one remaining. The odd one out. So then what happens? One of the negatives don't cancel. So everything pairs, 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 and then pair here, but then this is lonely. This has no pair. Therefore, what happens? Therefore, the overall answer is negative, and even more specifically, it's just a positive number. It's just a to the power of the odd number, the positive number taken to that power, and you negative it. So for example, negative 4 cubed, you could just calculate 4 cubed and then add a negative at the end. So it turns out 4 odd powers, this is equal. Not always equal, okay? These two are not always equal. For instance, if you did negative 4 squared, it's not equal to negative of 4 squared. Only for odd powers. So keep that in mind. And next we'll discuss some properties of powers. And in fact, we'll discuss 3 key properties, which are very crucial. So these are called the power laws, actually. There's a few power laws. So these are the 3 power laws. I haven't filled them in yet, but essentially what the power laws give you is a shortcut to compute these. Actually, also remember these. There's also these. Although we saw stuff like this in right. These two are quite similar to the square laws we talked about, because remember, a times b squared and a over b squared. It's basically the exact same thing with higher powers. But these first 3 are very important, and they're a bit more unique. So, the first law says, if you have a product of 2 numbers, 2 powers, what do? You add up their exponents together. So in words, product of powers causes summing of addition of the exponent. Again, remember, exponent is the terminology for the actual number up there. So don't confuse power. Power is the overall value, and exponent's just the singular thing at the top. Although, we're probably used to calling this the power. This is actually just the exponent. This entire thing is the power. So, how do you compute this? Sorry, how do you use this? Well, you can use this to simplify a lot of products of things into a single power. So for instance, if I have 2 cubed times 2 to the 5, and then I ask you, represent this under a single base. You'd notice you probably want to represent it under the base of 2, because the base is 2 here. What happens? The multiplication here becomes an addition inside the power. It's 2 to the 8. And in fact, you can check your answers. 2 to 8, 2 cubed is 8. 2 to the 5, if you check that, is 32. And 8 times 32 would be, use your calculator here if you want, but it will be 256. And if you check, 2 to the 8 would also be 256. Now, why is this true? The reason this is true is because of this. Let's actually prove this. Actually, I'm going to show you proof of just the 2 cubed times 2 to the 5 is 2 to the 8. Look at this. What's 2? Let's focus on the left-hand side. 2 cubed times 2 to the 5. What's the definition of powers? It's repeated multiplication. So this 2 cubed is 2 times 2 times 2. Whereas this 2 to the 5 is 2 times 2 times 2 times 2. It's 5 2's together. And remember, multiplication is associative, so the brackets really don't matter because it's all multiplication. Again, that's because there's only multiplication here. If there were other operations, of course the brackets would matter. But when it's just multiplication, you can ignore brackets. But how many 2's are multiplied together here? Well, you have 3 from here and 5 from here, so there's 8 2's in total. And if I have 8 2's being multiplied together, what's that? By the definition of powers, this is 2 to the 8. Actually, let me emphasize. I went from here to here again, the definition of powers, because powers is repeated multiplication. And then here, I use the definition of powers to go the other way, to go from the repeated multiplication to the power form. So, that's why this works. And actually, this proof works in general as well. You have a to the b times a to the c. What do you have? You have b a's here and c a's in the second part. So in total, you have b plus c a's, which is just a to the power of b plus c. And therefore, we're done. So that's the proof. Now, the other laws themselves are also very similar. The division one's basically the same. The proof is basically the same as well. And what it says is, it's quite similar. Instead of multiplication becoming addition, division of powers becomes addition. So actually, if I have 2 to the, let's do 4. 4 to the 5 divided by 4 to the 3. I could do this directly. And actually, if you check this, it's 1024 divided by 64. That's a bit tedious. But I can use the property, and I know the exponents will subtract. So it's just 4 to the 5 minus 3, which is 4 squared, which is very easy, which is 16. And if you do this division, you'll also get 16, but you'll have a lot more work to do. So that's why that's how you apply the division law. Now the last law is a bit more interesting. You have a to the b to the power of c. I should clear here. This becomes subtraction. Next law is the more interesting one, which says if you have a power of a power, what happens is this becomes a product. This is a to the b times c. And remember, multiplication is the only hidden thing, so it's just a to the bc. Now this is very powerful because this is quite different. You could have 2 to the power of 5 cubed, and instead of having to do this like this, just immediately go, this is 2 to the power of 5 times 3, just 2 to the 15. It's a big shortcut. So that is the power of a product. That is and this law is called the power of a power law. So the name of this is power of power. Sorry, that is not visible at all. Let me do a different color. Power of power, product of powers, and this law is called quotient, which is another word for division, I think, of powers. We'll touch on these later, because for now let's focus on these new laws, and in particular the power of a power law. Before that, let's actually get to a good practice question. The question is to express as a power of 2. Particular, let's have 2 to the 5 to the 6 divided by 2 to the 26. What do you have here? First, you apply the power of a power rule, just 2 to the 5 times 6 divided by 2 to the 26, just 2 to the 30 divided by 2 to the 26, and then you do the division law. Actually, you should name the law. I think it's at the very start, at least. Be explicit about which law you're using. And then finally use the quotient rule to subtract these. So I'll name it quotient of power. And look at that, this very complicated looking expression became something simple. That's just 16. Now again, you don't have to get 16. If you wrote 2 to the 4, that's fine, because all the question asks you to do is to express it as a single power of 2. And finally, the last one would be and the question still as a power of 2. So it seems a bit weird because we don't have a power of like 2 as the base anywhere. And the trick is this, to notice something, that 2 squared is 4 and 2 cubed is 8. And look at that, it's 2 squared to the power of 4 divided by 2 cubed squared. And if you use the power of a power rule, this becomes 2 times 4, which is 8. This we are done.